Hello everyone. Today we are going to start with chemistry chapter 1 for class 10, that is chemical reactions and equations. Now when we talk about chemical reactions, first we should know about physical changes and chemical changes. So in ninth class we had learned about that physical change is a type of change when no new substance is being formed. It is generally reversible, like if we cut a paper, then we can join it with the help of a gum. If we melt any ice, then we can put it back into the freezer. But in the chemical change, new substance will be formed which have completely different properties from the original compounds. For example, digestion of food, burning of fuels, burning of any thread, burning of any clothes, curdling of milk, etc. Now, whenever chemical change is there, we will say that chemical reaction is going on. In any chemical reaction, there will be some reactants and some products. So the reactants are the substances which are present before the chemical reactions. And the product means the substance which are formed after a chemical reaction. For example, if we look at this magnesium plus oxygen will give magnesium oxide, then we can say that magnesium and oxygen are the reactants and magnesium oxide is a product. So in this case, we have both reactant as well as product. Whenever we write any chemical reaction, we will say that reactants are on the left side and products are on the right side. We can also mention the state of the elements as well as the compound. Like magnesium is a metal, so it will be in the solid state. Oxygen is in the gaseous form, so we will write small g. Magnesium oxide is a powder, so we will write small s. Now, there was one question, why is burning of coal a chemical change? Explain in terms of properties of reactant and products. So in this question, we can say that when we burn a coal, it will combine with oxygen to produce carbon dioxide gas. So when we talk about reactants, coal has different properties, like it is in the solid form, it has different colors, but the product, that is CO2, it is containing different properties, like it can extinguish any fire, but coal is a fuel which can burn, and carbon dioxide has different property that it will extinguish any fire. Now let's move to our next one, chemical reaction. So it is a process where reactants like starting substance will undergo any chemical change to form product with entirely new properties. And whenever we write any chemical reaction in the form of symbols, like we can write magnesium as Mg, oxygen as O2, magnesium oxide as MgO. So we will say we are writing a chemical equation. Now in the last part, we have again one question. Why should a magnesium ribbon be cleaned with sandpaper before burning? So sandpaper is a paper with very highly rough surface. So we will answer it like magnesium ribbon should be cleaned with a sandpaper, because when we keep magnesium on the direct contact with atmosphere, it will form magnesium oxide layer on the outer part, and then when we try to burn magnesium ribbon, it will be very slow process. So first we will clean it with sandpaper to remove the outer layer, and after that when we try to burn magnesium ribbon again, it will be very fast. So for easier burning, we will rub it with the sandpaper. Before we start chemical reactions, equations, etc., we should learn about some valencies and the symbols of some specific elements as well as the group of atoms. Like we have +1 valency for these elements, then +2 for this, +3 for this, as well as the -1 valency, which are anions. Now, when we talk about characteristic of chemical reaction, they are the observable changes. For if there is any chemical reaction, so we can look and feel that there is some chemical reaction that is going on. For example, there can be some gas evolution, like bubbles or effervescences indicate a gas formation. So when we add zinc metal and sulfuric acid into it, then it will form hydrogen gas bubbles. For example, we add sodium carbonate and CO3 into HCl, it will give sodium chloride plus water plus carbon dioxide gas. Now these gases can be checked with certain chemical reactions. For example, when we bring any burning candle near this hydrogen gas, it will burn with a pop sound. If we bring lime water, that is calcium hydroxide, near this carbon dioxide gas, it will turn the solution milky. So we can identify exactly the name of the gas. Second characteristic is the formation of a precipitate. Now, what do we mean by precipitate? It is an insoluble solid which can be formed after combining two different substances. So it is the insoluble solid always. Now, when we mix up potassium iodide with lead nitrate PbNO3 twice, then double displacement reaction will be there and the ions will be exchanged. So it will form PbI2, that is the yellow colored precipitate, as well as the formation of potassium nitrate will be there. In the case of second example, AgNO3, that is silver nitrate, when we mix it with sodium chloride, it will form AgCl, which is the white colored precipitate, and there will be the formation of sodium nitrate. Third characteristic is change in color. For example, when we mix up two different substances, the color will be changed. When we mix up iron nail specifically into copper sulfate solution, the solution of copper sulfate, which was originally blue in color, will turn green. There might be some change in temperature, like when we mix up quicklime calcium oxide into water, it will form slake lime, and in this reaction high amount of heat is being released. So we can see that and feel that there is the release of heat. In other reaction, the temperature can be decreased too. So there are certain reaction in which temperature will be increased, and in certain reaction the temperature will be lower, and we call those reactions endothermic and exothermic reaction. Endothermic means heat is being absorbed, so the temperature will now cool down. Exothermic means the heat is being released, so the temperature will be now increased. Last one is change in state. For example, in starting the substance was in solid state or gas state, but after the reaction the state is being changed. We have one example that during combustion of wax, which is a solid hydrocarbon, after the reaction there will be the formation of carbon dioxide gas and water droplet. In the second reaction, when we mix up hydrogen and oxygen gas under a specific condition, it forms liquid water. So the conversion is from gaseous state to liquid state. Now we have a PYQ which was asked in 2017. State 4 observations that help us to determine whether a chemical reaction has taken place or not. So we can say that if there is any evolution of gas or formation of precipitate or change in color, change in temperature, so there might be the possibility that chemical reaction has taken place. Now we have law of conservation of mass, which was already we taught in class 9. It says mass can neither be created nor be destroyed in any chemical reaction. So total mass of element in reactant side will be equal to total mass of elements in product side. It was given by the scientist Lavoisier in 1789. So now according to this rule, we should have same number of atoms on reactant side as well as product side. So we need to balance a chemical equation, and for that we have a method which is known as hit and trial method, for which what we will do, we will first write any chemical reaction. After that we will make one box around them. Then we can calculate left hand side and right hand side elements. So for example, we have Fe plus H2 in the gaseous form, which will give Fe3O4 plus H2. Now at first we will write that Fe is in number 3, here number 8, here number 4. But in starting it was not a balanced chemical equation. For that, when we balance any chemical reaction, the atoms on left hand side should be equal to atoms on the right hand side. So what we will do, we will make one box in the outer part of Fe, H2O, Fe3O4 and H2. After that we will change the number by multiplying any, for example Fe. Here Fe is 3, but on the reactant side it was originally 1. So we will multiply the reactant Fe as 3. After that we will check if both are equal, then we will say the reaction is a balanced chemical reaction. We will solve multiple equations for this balancing method because it is a very important question which can be asked in your PT exams as well as your board exams. Now let's start with types of chemical reactions. First one is combination reaction. So according to the name we can say it is a combination of different materials. In a scientific term we will say that it is a type of reaction in which two or more element or compound will mix up together, combine together to form a single product. For example, during burning of coal, carbon will combine with oxygen to give CO2 gas. In formation of water, H2 and O2 will combine together to give H2O. When we burn a magnesium ribbon, Mg plus O2 will give MgO. When we combine calcium oxide into water, that is slaking of lime, it will give calcium hydroxide, that is slaked lime. If we combine ammonia and hydrochloric acid, then it will give ammonium chloride. So in this all the examples, two different components combine together to give a single product. So it is a type of combination reaction. Second type of reaction is decomposition reaction, in which a single reactant, for example AB, will break down in the presence of heat, light or electric current into A plus B. If the main component is heat energy, then we will call it as thermal decomposition, that is thermolysis. In this, we will say that it is a type of decomposition reaction which occurs in the presence of heat. For example, if we heat ferrous sulfate, that is FeSO4, which is generally in the solid form and it is of generally green color, so it will turn into Fe2O3 plus SO2 plus SO3 gas. Now this SO2 and SO3 gas have a pungent and smelly gas, so you can identify that the gas is SO2 or SO3 if the smell is like rotten egg, and the color of Fe2O3 will be a bit reddish brown, that is ferric oxide crystals. So we can say that combination reaction and decomposition reaction both are opposite from each other, because in one reaction two or more elements were combining together to give a single product, but in decomposition reaction a single reactant will break down to give two or more products. Now the second type we have, that is if we heat calcium carbonate, then it will give calcium oxide plus carbon dioxide gas. If we heat lead nitrate, in the presence of heat, it will break down into lead oxide plus NO2 gas plus oxygen gas. Now this NO2 gas has a distinct feature, that is it will produce red-brown fumes. So if the gas is reddish-brown color, then you can say that it is NO2 gas. If you heat copper carbonate, then it will give copper oxide plus carbon dioxide gas. If you heat potassium chlorate, that is KClO3, then it will give KCl plus 3O2. Now the last reaction is very important, because we say that if you want to commercially produce oxygen in the large amount, then we will use this reaction, that is potassium chlorate, and in the presence of heat it will produce large amount of oxygen gas. For the next one, we have electrolytic decomposition, which is a type of decomposition reaction that occurs by passing an electric current through any aqueous solution or a molten state of any compound. It is also known as electrolysis. So if you want to convert water into their separate elements, so we will pass electric current into it. But for that, we need to convert this water into a bit acidic or basic substance, because pure water is generally bad conductor and poor conductor of electric current, so the ions will not get separated. But if we add a few drops of sulfuric acid or hydrochloric acid, then it will produce ions and the electric current can easily pass through them. So water will be converted into H2 plus O2 gas. Now when we look at the formula, that is H2O. So in this, the hydrogen gas is double than oxygen gas. So the gas ratio will be also 2:1. In the case of sodium chloride, when we decompose it, it will produce sodium plus chlorine gas. In the third type, we have photolysis or photolytic decomposition, which we will identify as it is a type of decomposition reaction which is triggered or which is affected by the light energy. For example, if we keep halides of silver like AgCl or AgBr, then it will decompose to give grey colored silver as well as chlorine or bromine gas. And this reaction is helpful in black and white photography. Now for the next one, that is displacement reaction, we need to memorize metal reactivity series, which will give us the most reactive metal in the upper part and least reactive at the lower part. Now to memorize that, we have a mnemonic, that is please stop calling me a zebra, instead learn how copper had saved gold, which potassium will represent P, that is potassium, S for sodium, Ca is calcium, M for magnesium, A for aluminum, Z for zinc, I for iron, L for lead, H for hydrogen, which is for the comparison only, because hydrogen is a non-metal, but we need to compare these metals with water as well as acids, so we will put hydrogen in the middle part. Now then we have copper as copper, H for mercury, Hg, S for silver, and gold is gold. So the upper metals, potassium, sodium, calcium, are reactive metals. In the middle there is less reactive metal, and silver and gold are the least reactive metals which do not react with any other material like oxygen, gas, or any other acid like HCl, H2SO4, etc. So according to this reactive series, we will say that in displacement reaction, a more reactive element or a more reactive metal or non-metal will displace less reactive element, which can be metal or non-metal. So metal can displace metal, non-metal can displace non-metal. For example, if we have copper sulfate solution which is of generally blue color and put some iron nail into it, so after some time we will observe that the solution's color, that is blue, will change into a bit greenish color due to the conversion of Fe plus CuSO4 into FeSO4 plus Co, and the deposit of copper will be there on the iron, so iron will look a little bit reddish brown. When we put zinc into copper sulfate solution, it will turn into ZnSO4 plus copper. If we put lead into copper chloride solution, it will give lead chloride plus copper. If we put magnesium into HCl, it will give magnesium chloride plus H2 gas. So we will say that magnesium is more reactive, so it can replace hydrogen gas. Now in the second case, iodine and chlorine we have, so we will say that chlorine is more reactive than iodine, so it can convert into the other form, that is Cl2 plus Ki will give KCl plus I2. Now the most important question here is, why does the blue color of copper sulfate solution fade when an iron nail is dipped in? So we'll say that it is due to the displacement reaction. Now the next type of reaction is double displacement reaction. In this reaction we say that two compounds react by exchange of ions to form any new compound. For example, initially we have A and B and C and D, then the ions will get exchanged. That's why we will get Cb plus Ad. Now when we talk about exchange of ions, it will be either positive or negative. So for example, if we have AB and A is the cation, B is the anion. For CD, C is the cation, D is the anion. Then both of them will get exchanged. In the double displacement reaction, we have further two types, precipitation reaction and neutralization reaction. When we talk about precipitation reaction, we say that it is a type of reaction in which a precipitate is being formed. Now, precipitate is an insoluble solid which forms after any chemical reaction between two different compounds. Precipitate can be of any color like white, blue, green, etc. So it will act like an indicator that a chemical reaction is going on. For example, first we have a white precipitate. In this reaction, what we will do is we will add some sodium sulfate into barium chloride solution. After that, sodium will be converted into sodium chloride and barium will react with sulfate to become barium sulfate, and barium sulfate is the insoluble solid substance which is of white color. That's why when we mix sodium sulfate and barium chloride, we will get BaSO4 plus NaCl, where NaCl salt is the soluble salt, that's why it will mix up easily with the water, but BaSO4 will remain in the solid form. That's why we call it a precipitate. One more example we have, that is yellow precipitate formation. When we mix up lead nitrate, that is PbNO3 twice, into potassium iodide, that is Ki, it will form PbI2, that is the yellow colored precipitate, and also it will form potassium nitrate, which is the soluble form. For the next one, we have a complete table for different types of precipitates. First one, barium chloride plus sodium sulfate, which will give barium sulfate as a white colored precipitate. Second one, lead nitrate plus potassium iodide, that will give rise to lead iodide, which is a yellow colored precipitate. Third one we have, that is silver nitrate plus sodium chloride, which will give rise to AgCl, that is silver chloride. It is also of white color which turns grey in the presence of sunlight, which is also known as photolytic decomposition. When copper sulfate reacts with sodium hydroxide, it will form copper hydroxide and it is of pale blue color.
When iron chloride react with ammonium hydroxide, it will form iron hydroxide, which is of a bit reddish brown color. So according to this, the questions can be asked that which type of precipitate it may be, if the color is white or if the color is yellow. Now, next we have neutralization reaction. When we talk about neutralization, it is the interaction between acid plus base. Acid can be strong or weak acid, base can be also weak or strong base. For this, we have one example that we have NaOH into a single flask. After that, drop by drop, we will add hydrochloric acid solution. Now, when we mix up both of them, it will form sodium chloride salt and H2O. So first reaction we have, that is HCl plus sodium hydroxide will give rise to NaCl and water. Second one, H2SO4 plus KOH will give K2SO4 plus H2O. Third one, HCl plus NH4OH, it will give rise to NH4Cl. Next one is acetic acid CH3COOH plus NaOH, that will give rise to CH3COONA, that is sodium acetate. Next one is nitric acid plus calcium hydroxide, that will give rise to calcium nitrate CaNO3 twice, plus H2O will be there. Now when we talk about the nature of salt, salt can be acidic, basic or neutral according to the type of acid and base that were the reactants. Last one we have, that is redox reaction. In this reaction, oxidation and reduction both occur simultaneously. Now in the oxidation, there will be the gain of oxygen or loss of hydrogen or electron. In the reduction part, there will be loss of oxygen but gain of hydrogen or electron. In the redox reaction, one reactant will get oxidized but the other will be reduced. For example, first we have copper oxide plus H2, that will give Cu plus H2O. Here the H2 will be converted into H2O, that's why we can say H2 is oxidized. Copper oxide loses the oxygen, so we will say that copper oxide is reduced. In the second one we have ZnO plus C. So ZnO will be converted into zinc. So we can say that zinc oxide is reduced and carbon is oxidized. In the third one, MnO2 plus HCl, the MnO2 is converted into MnCl2. So we can say that manganese oxide is reduced and HCl is being oxidized. In the next one, H2S plus SO2, it will give rise to S plus H2. So we can say that sulfur dioxide is reduced and H2S is oxidized. In the last one we have H2S plus Cl2. Here we will talk about the gain of hydrogen and loss of hydrogen. Wherever there is a loss of hydrogen, it is known as oxidation. So we can say that H2S, hydrogen sulfide, is oxidized and chlorine is reduced. We have one more important practice question, that is identify the oxidized and reduced substances in Na plus O2 will give 2Na2O. Now in this reaction, Na is being converted into Na2O. So we can say that oxygen is being added into it. So sodium is oxidized but oxygen is reduced. Now, whenever we say that oxidation reduction reaction are there, there will be some agents which will help in the reaction. The agent which help in the oxidation process is known as oxidizing agent. The agent which helps in reduction of any material is known as reducing agent. For example, in this case, Zn plus CuSO4, that gives rise to ZnSO4 plus Cu. Zn is being oxidized. So we can say the copper sulfate here acts as an oxidizing agent. Now copper sulfate is being reduced. So we can say that zinc is acting like a reducing agent. That's why it helps in the reduction process of CuSO4. Now last two important topics are corrosion and rancidity. So when we talk about corrosion, we will say that it is the process, or it is a slow process of eating up of metals by the reaction of atmospheric gases as well as moisture. For example, when we talk about rusting of iron, rusting is the nickname for the corrosion of iron. So when iron react with water vapor, that is moisture, and oxygen, it will give rise to Fe2O3 into H2O. It is known as rust or ferric oxide or hydrated ferric oxide. Now, this hydrated ferric oxide is of reddish brown color. That's why the iron will turn reddish brown. If we want to prevent rusting, we can paint any iron material or put some oil or galvanize it. Galvanization is the process through which we will make one layer of zinc onto the iron articles. Second one is corrosion of copper, in which copper will react with water, oxygen as well as carbon dioxide. So it will be converted into basic copper carbonate, that is copper hydroxide into copper carbonate. And this copper hydroxide into copper carbonate is of green color. That's why we will say that copper is being converted from reddish brown to green color. Last corrosion is of silver, in which silver is a very less reactive metal, so it does not react with any water or oxygen molecules, but it can react with the hydrogen sulfide gas present in our atmosphere. When it reacts with H2S gas, it will produce a black coating on the silver articles. That's why we will say that when Ag react with H2S, it gives rise to Ag2S, that is silver sulfide, that is of black color. That's why our silver article or jewelry gets black or dark when it is exposed to the air for a longer period of time. Keep in mind that this process is a very slow process as compared with corrosion of copper or iron. Last one is rancidity. Just like the metals can get rusted or corroded in the presence of atmosphere, same way our oil containing food can also get bad smell as well as taste. That's why we need to preserve it. So rancidity is the process through which oil containing food like chips or etc., or oily food like junk material can convert into rancid food. That's why we'll say that our food is rancid, because it contains bad smell and taste. If you want to prevent rancidity, then we will put our food into airtight container, or to slow down the process we can put it into the fridge, or we can flush our chip packets with nitrogen. So everyone knows that the packets of chips have large amount of air into it, so those air particles are very important because it protects our chips from the atmospheric oxygen. Or we can add some chemicals like sodium benzoate, which are antioxidant, which will remove the oxygen and protect our oily food. Now we have most important reactions that needs to be practiced regularly, as well as we have some questions, so make sure to practice this. Comment if you have any doubt.